Thanks, Robert. Good morning, everyone. Good afternoon or good evening, depending on where you're joining from. Thank you for logging on to the session today. As Robert said, the session today is about understanding how you can secure your SQL Server with TLS 1.2. So before I go ahead and start, Robert, is everyone able to see my screen?
Right now, they're seeing the poll. Are you ready for me to close that poll?
Let's have a look at the poll.
So right now, we're at 58% no and 42% yes.
Okay, so there's a fair split of folks using Secure Channel in their environment. Okay, yeah, so let's go ahead and close the poll, and I will switch over to my presentation.
Great.
So is it showing my screen right now?
Yeah, we're seeing the presenter view at the moment.
Okay, I'm switching over to the slide view.
Perfect.
Okay, great. Okay, so before I go ahead and start, I'll just quickly introduce myself. I've been working with SQL Server for close to 10 years now. I work as a senior program manager on the Microsoft SQL Server product team. This team is known as the Tiger team. You will see us on Twitter using the MS SQL Tiger Twitter handle. We blog on the aka.ms SQL Server team blog, and we also manage our SQL Release Services blog, where we announce all our cumulative update and service packs, and that was the blog which had the announcement for SQL Server support for TLS 1.2. So what's the agenda today? So the agenda is going to be about TLS 1.2 and how TLS 1.2 works with SQL Server. So before I go ahead and start talking about how you can make SQL Server work with TLS 1.2, we need to understand why people are adopting TLS 1.2. It's not because there is a problem in how SQL Server does communications with its clients that connect to it. As of today, there are no issues reported with how we implement the TDS protocol for SQL Server. That's the protocol that SQL Server uses to talk to the database whenever any application or web server is making a connection to the database engine. Now, why would you actually move to TLS 1.2? So TLS 1.2 resulted because there were a lot of issues or a lot of security holes that were exploited in the past. There were various issues reported, like the Poodle, Beast, Freak. What these ended up doing was compromising machines or systems which were running either older versions of TLS or SSL, because of which most companies decided that TLS 1.2 would be the best way to secure their environment, both from a client traffic as well as from a database traffic standpoint. Now, the TLS protocol itself only secures your database end-to-end point traffic, that is your network traffic. It does not do anything to encrypt the data at the database level. It does not encrypt the file system. So there are other technologies available to do that. So if you want to encrypt data on the file system, you will either have to use third-party solutions or use transparent database encryption, which is a feature that ships with SQL Server. If you want to encrypt data inside your columns, then you have to use either column-level encryption if you're on SQL Server 2016. Then you have the option of using always encrypted, which ends up encrypting data all the way from the client back into the column without the database having access to decrypted. The client controls the encryption and decryption. If you have other solutions in place, you can implement them using like column-level encryption, using certificates, or protect with passphrases. So those are for protecting the actual data that sits inside your database. What we're going to talk about today is how to secure your network traffic once the network packet leaves the application or the web server, and then when it reaches the SQL Server database engine, how do we go ahead and secure that. Now, based on the recent issues that have been discovered, a lot of compliance that many companies follow, like PCI, mandates that you use TLS 1.2, and there are deadlines by which the company or the organization needs to become PCI compliant. But if the product doesn't support TLS 1.2, there is no way you could be TLS compliant, because you would not be able to use TLS 1.2 if SQL Server as a product did not support it. So earlier this year, what we did was we introduced TLS 1.2 support for all these versions of SQL Server. So SQL Server 2008 and 2008 R2, we found that customers still have both 2008 and 2008 R2 in production environments, and we provided TLS 1.2 support for those two products, even though they're in extended support, to ensure that you can remain compliant and work on upgrading to more recent versions of SQL Server while remaining compliant. SQL Server 2012, 2014, and 2016 are fully compliant with TLS 1.2. The KB that talks about all the different updates that you need for making your server TLS compliant is 3135244. This is one of the most visited KBs that we have right now, and when we go to the resources section, I'll point out the blog post that talks about TLS 1.2 support with SQL Server, which is one of our highly commented blog posts on our team blog. So before we move ahead and talk about what SQL Server supports and what kind of updates are required to have TLS 1.2 working in your environment end-to-end, let's understand how you would, or what you would use to encrypt your communication. So let's take a standard configuration here. So you have a bunch of users, and if you follow the laser pointer on the presentation, a bunch of users, which are your client machines. Let's say they connect to a set of web servers, then they go through a firewall or a proxy and hit the database servers which sit inside your data center. Now, you can use TLS 1.2 to encrypt the communication between your users and the web server. But if your SQL Server, which is a database server, did not understand TLS 1.2, you would not be able to use TLS 1.2 for the next phase of communication, which is between the web server and the database server. To ensure that both the web server and the database server are able to use TLS 1.2, which is a mandatory requirement for some compliances, you need to have both your web server and your database servers capable of using TLS 1.2 communication. So let's see what happens if TLS 1.2 is not understood by any one of the servers involved in the workflow. So think of this as a phone conversation. So let's say two folks are talking to each other, and if you look at this, I'm trying to simulate packets going between the two people talking to each other. As long as they speak a common language, you understand each other, you're able to communicate, you're able to exchange ideas. Now, if this communication changed either from a language standpoint or they were sent in a different way, which the other party did not understand, then it becomes a problem. So what happens when you encrypt your network communications? The party that's sending the packets across, they would lock it with a key or a protocol which the other side would not be able to understand. So what SQL Server is going to do is going to be pretty drastic. You're going to have a situation where the SQL Server does not understand the traffic. This could lead to two states. It could either lead to SQL Server not being able to reply back, which means SQL Server does not respond to any queries, or SQL Server could not start. One of the two is possible. So let's see what is required with TLS 1.2. So if you want your server to work with TLS 1.2, SQL Server divides itself into server-side components and client-side components. So for the server-side components, the database engine, so the KB that I talked about earlier, has a list of updates that the database engine requires for running TLS 1.2. Integration services itself does not require any special updates. However, there are tasks in SSIS which allows you to make connections to FTP servers, to web services, to make web service calls, or even execute .NET code. And if your SSIS packages which are running on the server do any of these, then you need to make sure that the Windows Server supports TLS 1.2. So you need to have either Windows Server 2008 R2 or above with the required patches which supports TLS 1.2. And if they're using a web service or using a .NET component, which is below .NET 4.6, then you need to go back to our KB and see which .NET updates need to be applied. So that KB has a list of all the .NET framework updates that are required to make TLS 1.2 work with your components. For reporting services specifically does not require TLS 1.2. However, there are a few components which are .NET components and connectivity components which require TLS 1.2 support, which means the Windows operating system on which the reporting services instance or service runs on needs to have TLS 1.2 support. The .NET framework on the server needs to be updated with the latest updates which support TLS 1.2. And the last thing is the client connectivity components. Because reporting services is an application that talks to the database engine, the driver that reporting services uses, which I will talk about under a known issue section, needs to be updated to support TLS 1.2. As I said, the lowest Windows OS that supports TLS 1.2 was Server 2008 R2. .NET framework, we will get through these, how many different types of fixes you need to make sure that all different functionality that SQL Server uses from a .NET standpoint is able to use TLS 1.2. The most common client drivers that we have today are SQL Server Native Client, ADO.NET, and the ODBC driver for SQL Server. These are the three drivers that we find most commonly on the system, and if you have a Java application, you would have the JDBC driver. All these drivers support TLS 1.2. You need to ensure that you download the right update and update the client drivers on both the server, because the server also has a set of drivers, and also it needs to you need to push out these updates, these client driver updates, to all the clients and web servers which use TLS 1.2. Robert, any questions so far?
I had a question asking, so for SQL 2008, 2009 R2, what are all the patches one needs to have to be compliant? SP4, SP3, and TLS 1.2, is there anything else? So far, I pointed them to the KB3135244, which lists all the patches you need to get TLS 1.2 support for SQL Server and the download links to them. Do you have anything more to add to that?
Yeah, so that KB has all the lists. Thank you, Robert. That has a list of all the updates required for the server to support TLS 1.2 for SQL Server 2008 Service Pack 4 and SQL Server 2008 R2 Service Pack 3. You will need to download the database engine update, which is listed in the first table in that KB article. And for the second one, which is the client-side components, you will need to download the updates for SQL Server Native Client, ADO.NET, and if you have ODBC driver for SQL Server or JDBC driver, you need to download those as well. But for 2008 R2 and 2008, it's highly unlikely that you have the Microsoft ODBC driver for SQL Server installed.
Okay, another question. After disabling SSL and TLS 1.0, 1.1, only TLS 1.2 is enabled. Connections to SQL Server fail if using the SQL Server driver, Microsoft SQL Server ODBC driver version 6.01.7601 or the Microsoft OLEDB provider for SQL Server. We get a SSL security error, and this occurs even with all the patches to support TLS 1.2 installed. Will these legacy drivers ever support TLS 1.2?
Okay, so that question is a good segue for me to move on to the next slide. I will answer that question in two parts. So if you have an older operating system, you will have to add these keys, what you see on the screen right now, to support TLS 1.2. So the TLS 1.2 client, the disabled by default key should be set to 0 and enabled should be set to 1. TLS 1.2 server should be set to disabled by default, again 0, and enabled needs to be set to 1. The server key controls the server-side components, the client key controls the client-side components. If you don't have these set, the server will not use TLS 1.2. The way the protocol negotiation works in Windows is it picks the least possible denominator. So if it has a server which supports both SSL3, TLS1, and TLS 1.2, and the client supports only TLS1, then it would pick TLS1 because that's the lowest common protocol supported by both machines talking to each other. So if you look at the text below those registry key settings, you will see that disabled by default and enabled settings are required only for our Windows 7 clients and Windows Server 2008 R2 servers. On Windows 8 and later versions and Server 2012 and above, these operating systems already have support for TLS 1.2, so these keys might not be required depending on the application that you're using. Some applications can hardcode to use only a specific protocol. So in terms of the older drivers, so for one, if these keys are not set, if you're running on older operating systems, you will not be able to use TLS 1.2. If you disable all the other protocols and you want only TLS 1.2 enabled, then you have to create the registry keys for all the other protocols under the same registry hive that you see on the screen and set enabled equal to 0 so that all those protocols are disabled and the server understands and the client understands that the only protocol supported is TLS 1.2. The OLEDB driver, that does not have TLS 1.2 support, and as of now, there isn't a plan to support TLS 1.2 for that driver. So any application that is using that should either upgrade to using a more current driver like the Microsoft ODBC driver or a SQL Server native client or any of the other client drivers that support TLS 1.2. Robert, is there any follow-up question post that for that particular topic?
Yes, there is. So Jeremy Davison asked, he said, with these registry keys, I had to completely remove the disabled by default key for both the client and server for TLS 1.2 to work for SSRS. Is there a reason for this? Server was 2012 R2.
Okay, we're not aware of an issue like that, but for SSRS configuration manager to work, there's a specific registry key that is required, which I'm showing right up here. We're not aware of an issue that is being mentioned. So if you could reach out to us through our blog, or if you could go to our blog and use the contact form to send us a note on the behavior, I'd be more than happy to look into it.
I have one final question if you'd like to hear it.
Sure.
Thomas Shakur asks, if Windows OS has TLS 1.2 enabled, does SQL Server also need to have it enabled?
So the question is, if Windows Server has TLS 1.2 enabled, does SQL Server require it? No, so SQL Server does not have a specific set of registry keys which is used to denote whether TLS is required or not. Whenever a client connection is made to the database engine, a protocol negotiation happens between the server and the client. The client will determine what is the protocol that it can support, and it will ask the server. The server will then reply back whether it supports that particular protocol or not. And till a common protocol is reached, the negotiation keeps happening. It starts with the highest level available, and it goes down to the lowest level possible. If it does not find any common protocol between the client and the server, then the communication basically reports an error saying the connection failed. For SQL Server to work with TLS 1.2, you need to have the updates for both the server-side components and the client-side components, because without that, the connection cannot be made because SQL Server does not understand TLS 1.2 traffic. So if you have a system where you've disabled all other protocols other than TLS 1.2 and you don't have the updates, SQL Server, if the server-side components are missing the updates, it will fail to start. If the server side is updated and the client does not have the necessary updates to negotiate TLS 1.2 communication, then the client connection will fail. So let's go over to the next slide. This would probably make things a bit more easier. So let's talk about a simple topology where you have a failover cluster instance, which is SQL Server 2014 or below. Let's say you have a bunch of web servers serving that particular failover cluster instance, and you have applications connecting to the SQL Server in two different forms. At the bottom, you see there are two clients connecting to the web servers. On the side, you see a single client connecting directly to the SQL Server instance. So let's talk about what are the updates required. So for the SQL Server instances support TLS 1.2 communication, you need to apply the database engine patch for, if it's SQL Server 2014, the 2014 patches. If it's 2012, the 2012 patches. Basically, the patches required for the database engine for the release that you're running needs to be applied on all the nodes of the failover cluster instance. This will ensure that the database engine is able to support TLS 1.2. If you're using database mail, there's a specific .NET framework update which is required so that database mail can use TLS 1.2. Once you configure a server which is running SQL Server to only use TLS 1.2, then database mail also has to use TLS 1.2, and it does not have an option of switching back to a lower protocol. So in situations where this .NET framework update is missing, you will find that database mail sessions fail and no mails get sent out using database mail. So if you have any alerts being sent out, it is very important to have this .NET framework update. What the .NET framework update does is it allows the older versions of .NET to use TLS 1.2 protocol when they have been used in applications or executables like database mail. For the applicable client-side components like SQL Server Native Client, ADO.NET, or ODBC driver for SQL Server, or the JDBC driver, you will need to install all the updates for all the applicable drivers on all the nodes of the failover cluster instance. Otherwise, client communication will not work. So if the client that you see at the bottom, which connects directly to the failover cluster instance, is making a connection which only requires TLS 1.2, then this connection will not work because SQL Server 2014 without the client updates will reject the connection because it just doesn't understand the traffic coming in. Now let's see what happens with the web servers. On the web servers, the story is a bit different. You need to apply all the .NET Framework updates because you might have components like FTP tasks, or you might have components like web services which talk to the SQL Server instance. In those cases, you definitely need to apply the required .NET updates to ensure that TLS 1.2 is supported from a .NET standpoint. And also, the web servers are actually clients here which use client drivers to connect to the SQL Server instance. So all the applicable client-side components will be needed. So if you have SQL Server native client, or if you're using the ODBC driver for SQL Server to make a connection from the web server to the SQL Server instance, you will require the client-side component updates to make the connection with TLS 1.2. Now, let's see what updates are required for the client, the standalone client that you have. So for the standalone clients, you don't require any updates for the clients that are connecting to SQL Server using the web servers, because as long as the operating system and the web traffic is encrypted using TLS 1.2, there are no SQL-specific updates that are required to those clients, because those clients don't directly talk to SQL Server. So these are the clients that are connecting to the web service. The client which is not connecting to the web server, which you see pulsing on the screen, requires updates to the client-side drivers, because without this, the client would not understand TLS 1.2 traffic. So the applicable client-side driver updates are required to ensure that SQL Server client, in this case, the standalone client connecting directly to this failover cluster instance, is able to use TLS 1.2. Any more questions, Robert?
Nothing further yet.
Okay, great. So let's move on. Let's talk about what kind of issues you will face if you don't update. So whatever I talked about right now, if you don't follow the required, follow these steps and apply the required updates in your entire topology, what are the kind of issues that you could face? So the first known issue that might happen is if you have a client which connects to the database engine and you have updated only the topmost part, which was the failover cluster instance in my slide, in my previous slide, you would see that the client is unable to connect. You get various connectivity-related errors, and all of these point to the fact that the client driver or the client application is not able to connect to the SQL Server instance. So if you go to that KB article, you will need to download the SQL Server client updates. In this case, for reporting services and for Management Studio and Report Manager, you need the ADO.NET update for supporting TLS 1.2 communication. So this is specific to the ADO.NET driver, which the Management Studio, Report Server, or the Report Manager uses. The other known issue is around availability groups or database mirroring or service broker. All of these endpoints use the service broker methods or the service broker protocol, and if you're encrypting that endpoint for the service broker or the availability group or the database mirroring, the endpoint traffic can fail if both the servers don't have the required database engine updates. So if you require the database engine to support encrypted communication for our availability groups or database mirroring or service broker, then you need to have the required TLS 1.2 update applied to all the servers that are part of that topology. Otherwise, the communication will fail, and the moment you restart your SQL Server after ensuring that you've made the required registry changes, the SQL Server will either not start up, or if it does start up, it will fail to communicate for that particular setup. Now, this is a rare issue, but we have seen a few instances of this problem where TLS 1.2 is the only protocol enabled on the server. All other protocols on the server have been disabled, and due to this, when a new SQL Server setup or a new SQL Server instance which is being installed, it fails with the errors that you see on the screen. And this is primarily because of the fact that when you are running SQL Server Setup, there is a phase where SQL Server Setup starts up the service and runs configuration for the instance. And if TLS 1.2 is the only protocol that's supported, the base driver that SQL Server Setup installs does not understand TLS 1.2. So what you need to do is you need to ensure that the required .NET fixes have been applied and rerun the SQL Server Setup. One of the workarounds that's possible is enable one of the older protocols so that setup can use that to configure the server. Once the setup is completed, you can disable the older protocol and have your server running only with TLS 1.2. If you do that, you still need to apply all the necessary .NET fixes, because once the setup is complete, you still need to connect using TLS 1.2, and that would not be possible if you did not update all your client drivers and the database engine with the required updates. Another known issue is using a certificate. We talked about a previous known issue where the encrypted endpoint is not supported. We have seen instances where there are old certificates which use MD5 hash algorithms. These are not supported for TLS 1.2, so the protocol does not support MD5 hash algorithms when used to encrypt endpoint communication between two SQL Server instances. So you would have to change the certificate and move to a non-MD5 hash to ensure that the endpoint communication can be encrypted using TLS 1.2. So this known issue is also documented in the KB article. We have seen quite a few support incidents raised with Microsoft for this particular issue, because the certificate that was there was a pretty old one and it did not support TLS 1.2, even though all the servers and client drivers had been patched with the required updates. So this is a very specific scenario. If you have an old certificate, it might be a good task to check if they are using MD5 hash or not before switching to TLS 1.2. We talked about the database mail issue a little while back. We have a separate section which talks about additional updates required. So these .NET Framework updates ensure that TLS 1.2 is supported for the .NET API calls that database mail makes. And once you apply these updates, your database mail can also continue to use TLS 1.2. If you don't have this .NET Framework update installed for the required operating system, but you have the SQL Server update installed, then SQL Server will continue to use TLS 1.2, but database mail will continue to fail. So Reporting Services Configuration Manager, we've seen this for a few cases that were reported to Microsoft. You are unable to connect to SQL Server using the Reporting Services Configuration Manager, even though you have all the client driver updates. In that case, the registry DWORD enabled is required for TLS 1.2 client. Once you set that to 1, you're able to connect to the SQL Server Reporting Services Manager. Robert, any questions so far?
Yes, I have a few questions for you.
Okay.
Cal Malone asks, what is the severity level of the errors received within SQL Server in reference to the slide where you talked about KB article 3135769?
3135769. Okay, so let's pull that up. So this depends on what the operating system understands. So if the operating system understands the error, it will report a specific severity level, but sometimes it might not be a good idea to check for a particular severity level because it depends on the operating system. If the operating system does not understand the protocol, or you're on a client driver version which absolutely did not know what TLS meant, you will get a very, very generic error, which is why I've put that on the screen. And just by looking at the severity level, which you wouldn't find, you would not be able to react to the error. So our recommendation is to not specifically look for a pattern or a phrase, because depending on what version of the driver you had when you were experiencing the problem, it might be possible that the driver does not know what TLS means, and it will just give you generic connectivity error stating that the server does not exist, or some other error which would make it seem like you have a network problem connecting to the server and not a secure channel problem.
Great. Kyle also asks, will DB mail failures be recorded in sysmail _ failed items?
Yes. So whenever the database mail fails, your items will be unsent or in a pending state, depending on what timeouts you have set. And if you look at the agent log, you will see the error that you see up on the slide right now.
Okay, great. And Norberto Santon asks, after we install the patch to SQL Server, and if we have two different clients, one with the patch and the other not, will the not patch client be able to connect anyway? Will it pick a lower protocol?
I'm not sure I understood. If you could repeat that, sorry, Robert.
I think he's asking if he has one client that's configured to use TLS 1.2 and one that's not. Will the one that's not still be able to connect with TLS 1.0?
Okay, so for the client that's not configured to use TLS 1.2, it depends on what settings have been put in the registry. So if for that client machine, all other protocols other than TLS 1.2 have been disabled, then this client will fail to connect and will report an error stating that it is not able to make any connection to SQL Server. If it understands the TLS protocol, it will report that it does not find a common negotiated protocol. If it doesn't, it would give a generic network connectivity error, a general network error. If the client OS does not support TLS 1.2, then even if you have the client update, it's not going to matter because the OS does not support it. I hope that answers the question.
Great, thank you, Amit. That's all the questions at the moment.
Okay, great. So let me just switch over to the KB article and the blog just to show what kind of information we have there, so that it's a bit clear for everyone. Because I referred to the blog post quite a number of times during my session right now. So give me a moment while I switch over to the blog post. So Robert, is this visible?
Yes, it is.
Okay, great. So let's look at the blog post first. So I talk about very high level what the fixes are and what the known issues are, and these are what we were talking about. So to the question on if the client fails, if it did understand the TLS protocol, it would report an error, something like what I have highlighted in the event logs. It would say that the S channel source would be S channel. It would report that there was no defined protocol that was available to make the connection, and it would also clearly mention that none of the cipher suites available on the client application are supported. So this is a very clear indication, and this is what you should be looking at in the event logs. This would be a very clear indication that SQL Server or the client is using a protocol which is not supporting TLS 1.2. But these are for drivers which understand the TLS protocol. There might be drivers which are pretty old and were not aware of TLS, so they just end up throwing very generic errors. The other thing to keep in mind is when you look for these errors, it's very, very important to know what your allowed protocols are on the server. So the first thing you would want to check is the registry settings and find out what protocols are enabled. And if something is disabled and if you're troubleshooting, try enabling those protocols and see if it works. If it works by enabling an older protocol like SSL3 or TLS1, then you definitely know that this is a TLS-related issue. And the problem that happens is when the communication fails at a protocol negotiation layer, you have not even touched or entered the SQL Server engine. So most of the error messages would be at the connectivity layer, and there would not be any interfaces available to find out if that connection failed. So in an upcoming service pack for 2014, we would add a capability for a bid trace to track down what kind of protocol is being used, and we're actively investigating how to make diagnostics available to determine if TLS 1.2 has been used or not, so that it makes it easier to debug issues when you're troubleshooting either connectivity failures or you're troubleshooting issues related to just TLS connection problems because an update is missing. So if you switch over to this KB article from the blog, it talks about all the different SQL Server builds that support TLS 1.2, and you will notice that all the builds that are currently available, or all the release branches that are currently available in the market today for SQL Server, has support for TLS 1.2 through one update or the other. So for SQL Server 2014 and 2012, you will have the cumulative updates listed along with the service pack, which supports TLS 1.2. The only reason you do not see SQL Server 2016 in there because SQL Server 2016 RTM supports TLS 1.2 out of the box. So the way to read this is SQL Server 2014 Service Pack 1. If you have that, the minimum build that supports TLS is build 4439. If you install that, and if you're on any build higher than that, you obviously have TLS 1.2 support. And this is only for the database engine. The first table only talks about TLS updates for the database engine. The second table talks about all the client updates. The way to read this table is you have a SQL client which is using .NET Framework 4, 4.5, or 4 or 3.5. You need to apply the .NET Framework update which is applicable for your operating system. So if you're using .NET Framework 4.5, the ADO.NET update would be the second one if you are patching Windows 8 or Windows Server 2012. If you're patching Windows 8.1 or Server 2012 R2, then you require the first one. A similar case, if I look at ADO.NET for .NET Framework 3.5, then if you're patching Server 2008 Service Pack 2 or above, or if you're patching Windows Vista Service Pack 2, then you require the first one. If you're running on Windows Server 2012 R2, then you require the last one. For native client, depending on what platform of native client you're running, whether it's x86 or i64, you only have to pick one. For native client for 2008, again, you have to pick one. For native client for SQL Server 2012 and 2014, there's only one native client that you need to download. For the ODBC driver, again, for 2012 and 2014, there's only one. The ODBC driver for SQL Server 2016 already supports TLS 1.2 out of the box. For JDBC driver, again, depending on the JDBC driver version, you need to download the right JDBC driver. These are the additional .NET Framework fixes required for TLS 1.2 for database mail and certain other components in SSIS. As I mentioned, like if you're using FTP tasks or if you're using web services, then you require these .NET updates, and depending again on the Windows operating system that you're running and the .NET framework, you need to download the appropriate .NET update and apply it on the server. Any questions, Robert?
No new questions yet.
Okay, great. So essentially, this is a long list of updates that are required, but there are different components that support TLS 1.2, and depending on how you have set up your system, there will be various other components that either require an update or work out of the box. So this KB article does have all the associated fixes that are required to make your SQL Server topology work with TLS 1.2. If you do find something that is missing, or if you find that there's something that you're unable to understand, we're more than happy to receive feedback. You could either leave a feedback on this particular blog post, or you could use our contact form on our team blog, which is aka.ms SQL Server Team, and send us feedback, and we're more happy to understand what the feedback is and why that's a problem, and work on improving the documentation in the KB article and the blog. So if you look at all of these fixes, everything has a version associated with it. It is possible to automate a lot of this. If you've downloaded all the fixes, you can automate these using PowerShell. The most easiest way to automate this using PowerShell would be to check the win32_product class. So let's go ahead and look at that. So let me switch over to my PowerShell window. So what you see on your screen right now is essentially two checks. First, the native client check. So what I'm doing is I'm using win32_product. I'm searching for native client, and I'm picking the name and the version. And depending on the version that I find, for example, the first version that I look for is 2012 and 2014. So I look for 6538, which is the driver version that first started supporting TLS 1.2. If that's the version available, then I don't need to do anything. If it's not, then I mention that it needs an update. If it's Server 2008, then I look for 10.6538. Yeah. Okay. So I think I need to update that. So for the version which is 2008 R2, which is 6537 and 50, this is the update that I require. So basically, I'm doing a programmatic check. So you would need to run this PowerShell script on all the servers and clients to determine if the SQL Server native client driver needs an update. So that saves a lot of work from going down add remove programs and looking at versions of the products installed. The other one is the ODBC driver. These are the two most common drivers that we find on all SQL Server installations and clients. So which is why I'm showing you how to automate the updates for the ODBC driver and the native client. So again, for 2014, I check if it's version 12 and greater than 4219, which is the build that started supporting TLS 1.2. If that's the case, then you don't require the update. If it isn't, if it's below that version, then you require the update. So let's see what happens when you run this particular script. It's going to basically pick out the products. It's then going to go ahead and check if the build matches the one that we have in the if condition. If that's the case, it's going to go ahead and publish, or it's going to print out an update required. So my native client requires an update to support TLS 1.2, and I have SQL Server 2016 installed on the box, so I will have the latest ODBC driver. So it mentions that that's not required because that version already supports TLS 1.2. Similar kind of automation can be written to automate the database engine checks as well. So I have uploaded this particular PowerShell script to GitHub. I will share the GitHub link once the session is done. And you can download the script. You feel free to modify it. Feel free to contribute to the GitHub repository. I will keep updating this for other aspects so that version checks are more automated, which you can run against your servers and clients to save you the time for finding out what fixes are required. Any questions, Robert?
No questions yet.
Okay. So I'm going to go ahead and stop or remove the IE windows. So let's go back to the PPT. Let me go ahead and share the collateral that's available publicly. So these are the resources that's available. So the scripts are available on GitHub under MS SQL Tiger demos. As always, we appreciate feedback. So depending on how the session went and what you thought of the session, we would like to hear your feedback. So if you could go to that link, which is spoke.at/tigertls, if you could give us feedback on the session, that helps us improve for future sessions. The blog post that I talked about is right up on the screen, and the KB article is 3135244, which has links to all the other KB articles which have known issues associated with the usage of TLS 1.2 with Microsoft SQL Server. Our team blog, SQL Server team, this is where we keep updating our blog with posts on new features or new improvements that we're doing for the product. So all of these keep showing up on our blog, so stay tuned. We're launching SQL Server 2014 Service Pack 2 next month, so you will see a new set of blog posts coming in which talk about the improvements in SQL Server 2014 Service Pack 2 in detail. And we're also on Twitter under MS SQL Tiger, so any of the improvements that we blog about, we will share them on Twitter as well and other social media channels. So once again, thank you for attending the session. Thank you, Robert, for setting this up and providing a time slot where we could come in and present. Appreciate it. And for those of you in North America, long weekends coming up, have a good weekend and enjoy the time off.
Thank you, Amit. And several of the attendees have expressed thank you as well for answering their questions and for presenting. I'm going to go ahead and display the results of the poll we had at the start so everyone can see what the results were. And just a reminder, this will be